Welcome to O'Reilly Maths. This is the 2019 Leaving Cert Higher Level Paper 1 and we're looking at question number 3. Part A says factorize fully 3xy minus 9x plus 4y minus 12. So it's probably junior cert since you've seen a factorization like that, so hopefully you remember. There's no common factor to all four terms, so factorizing by pairing is something that we can try. If we factorize this pair and then factorize this pair and see if there's something common. So what can I factorize out about these terms? Well, I can take 3x, factorize that out. 3x into this goes y. 3x factorized out of minus 9x is minus 3. And for these two terms here, I can factorize out 4, positive 4. When I factorize 4 out of the first term, I get y. If I factorize 4 out of negative 12, I get minus 3. And what I have then is a common multiplier here. I've got y minus 3 and y minus 3 here. So I've got 3x multiplied by y minus 3 plus 4 multiplied by y minus 3. So I can actually write that as 3x plus the 4, both of them, multiplied by the same thing, y minus 3. So I can write it like that. Okay, so that's it factorized fully now, into brackets, factorized. Okay, part B. I have a feeling we're going to be using this because that was a very easy question for Leaving Cert Higher Level. Part B says g of x is equal to 3x multiplied by the natural log of x, or ln x, minus 9x plus 4 times the natural log of x minus 12. So we have this function g, and it says using your answer to part A, or otherwise solve g of x is equal to 0. Okay. So I suppose what you should spot here is that the only difference between this expression here and the right side of this function is here, where you have y here, sorry, that should be just the y and y there. So you've got 3xy minus 9x plus 4y minus 12, and here you've got 3x ln x minus 9x plus 4 ln x minus 12. So the y here has changed to ln x. That's the only difference between these. So that's how we're going to use this. So we can write g of x. If we use part A, you can write it's 3x plus 4 times y minus 3, but the y here in this case is ln x, so it's times ln x minus 3. So just what all we've changed there is this y has changed to ln x. So that's how we're using part A. And then we want to see when we want to solve this when it's equal to 0. So when this function is equal to 0, we would have 3x plus 4 by ln x minus 3 equal to 0. So we're going to solve this now. So a bracket multiplied by a bracket is 0. So split screen, either the first bracket is 0, 3x plus 4 is 0, or the second bracket, ln x minus 3 is 0. Okay, so if 3x plus 4 is 0, well then 3x is equal to negative 4 when you bring the 4 over, which means x is negative 4 divided by 3. Divide both sides by 3. So that's one answer. Okay, and the other answer is if ln of x minus 3 is equal to 0, well then the ln of x, or the natural log of x, is equal to 3 when you bring this negative 3 over. And remember, the natural log of x is really just log to the base e of x is 3. That special number e. Remember, e is just a number. It's about 2.718. So What is a log? Well, the log is the log of a number is the power that the base must be raised to. So if you rearrange this, what you get is x is equal to the base to the power of 3. So x is e cubed. E cubed is 2.718 roughly cubed, but you can leave it like that. So your two answers are -4/3 and e cubed. So that's part B done. Okay, and finally part C. Evaluate g dash e correct to 2 decimal places. So the derivative of the function with e substituted in. So first of all, we'll rewrite g of x first. So remember g of x, and we'll go back to the original form. G of x is 3x ln x minus 9x. 3x times ln x minus 9x plus 4 ln x minus 12 plus 4 ln x minus 12. So I'm rewriting the original function. I'm going to take my time with this. Then I'm going to find g dash x, or the derivative of the function. And once I find that, then I'll substitute in the e for x. So I'm going to differentiate each of these 4 terms, okay? Now be careful here. The first term is the product rule because it's 2 separate functions of x. So the product rule, we'll apply that. So that's going to be equal to 3x multiplied by the derivative. So it's the green multiplied by the derivative of the yellow. The derivative of ln x is 1 over x from your tables book, plus the yellow multiplied by the derivative of the green. So plus ln x by the derivative of the green, the derivative of 3x is 3. So I'm applying the product rule there, which is in your tables book. Okay, so then I'm going to differentiate this term, minus 9x, the derivative of that is minus 9. And then 4 ln x, the derivative of 4 ln x is 4 by the derivative of ln x is just 1 over x. And the derivative of -12, a constant, is 0. So there we have our differentiated function. And now we're going to find, now we're going to find g dash of e. So we're going to replace the x now with e, the number e. So 3x, instead of 3x, you've got 3 times e over 1, multiplied by 1 over e. So 3 times e times 1 over e plus log to the base e of 3 Sorry, I'm missing, what am I missing there? I'm missing ln x there, I'm missing x. Log to the base e of, let's do that again. Sorry, so that's plus ln of x, I was missing, left out the x there. So ln of x by 3 is just 3 ln x. But we're not going to put in the x, we're going to put in e, okay, 3 ln e, minus 9 plus 4 times 1 over e. Okay, so again, I've just replaced all the x's up here with e's, okay? So what do we got? 3 times e is 3e by 1 over e. Well, that's 3, the e's cancel. Plus 3 times ln of e, remember that's the log to the base e of e. minus 9 plus 4 times 1 over e is just 4 over e. Okay, so 3 minus 9 is minus 6. 3 times the log of e to the base e. Well, what power do I raise e to get e? Well, that's 1. So that's plus 3 times 1. And then I have my 4 over e at the end. So now minus 6 plus 3 times 1 is 3. Minus 6 plus 3 is minus 3. Plus 4 over e. So that's my answer in terms of e. And you can evaluate that in your calculator if you want. So that would give you, on the calculator, remember they want 2 decimal places. So that would give you, on the calculator, minus 1.53 when it's rounded. Okay, so that's the answer to part C.